Good evening, everybody. My name is Yelena, and I'm with Data Analytics program at University of Maryland University College. And today I'm going to do an introductory presentation about R and RStudio. So here's an agenda for today. We're going to review the RStudio environment, and I'm going to show you how to install and load packages. I'm going to explain to you what it is. And I'm going to show you how to create a script, and I'm going to show you how to load data, and we're going to go through how to display the data property, how to check for missing values, sorting, and more. So let's go ahead and get started. I'm going to launch the RStudio. So most of you, this is my understanding that most of you may have installed RStudio already. So here we've got three main panels. Here is a console panel. This is where you're going to type your code, and this is where you're going to see your output, right? Oops, am I sharing? I'm not sharing. Let me go ahead and share again. I'm going to go ahead and share my screen. Sorry. Oops, so let's minimize this. So now you can see it. All right. So here is the RStudio. Here are three panels that I was talking about, and this is a console. So here is where you're going to type your commands, and you can see your output in here. Here you have an environmental window. Right now it's empty because I have not really done anything. I just launched RStudio. And here you see the files in the current working directory. I'm going to show you what the working directory is. And the plots, of course, I have nothing at the moment. And the help window and the packages. I'm gonna discuss what packages is shortly. So what I'm gonna do right now is I'm gonna type my first R command just to confirm. Right, I'm gonna type R version. This is just to verify that I have the correct version of RStudio. And you need to have 3.3.1. You always want to have the latest version, right? Now, so what I'm going to do right now is I'm going to show you how to load data. But before we do that, this is very important. We need to set the working directory. Working directory is a directory where R looks first. So if I want to open a file, perhaps, right, the first thing it's going to do is going to look for that file in that folder. So what I could do, there is more than one way to do it. I can do it programmatically, or I can just do this. This is set working directory, and then I'm going to select the location. Oops. So this is session, right? Set working directory, and then I'm going to choose the directory. Now, again, something to keep in mind is that this is going to be effective only for the current R session. Okay? So what I did was I have a separate folder on my external hard drive, and I call it datasets, and I've been saving all datasets in that folder. So what I'm doing right now is I'm going to set it as my folder, okay, so basically secretly behind the scene, what R did for me, it ran this command to set the current working directory to this folder on my external hard drive. And notice that in here, in this title bar, it shows you what your current directory is, right? So whenever, if I want to open my files, it's the first place where it's going to look at. Right. So some of you may have done it for the earlier homework assignment where you use the data set that comes already with R installation, such as iris data or infertility data, right? Some data sets come with RStudio installation. However, what you're going to do in a later assignment is that you want to load your own data. There is more than one way to do that. To load your own data, you can write the command, or look at this, tools, right? And I'm going to do import data set from local file. Again, it's tools, import data set from local file. Okay? Now, what is this? By default, it's going to open my local my working directory folder. Do you remember I just set the dataset to my working directory folder? And what I'll do right now, I'm gonna find my dataset. This is equivalent dataset that I wanted to use. I'm gonna hit open. Now here, this is the name of the data frame. Data frame is an object into which my data is gonna be loaded. The top section right here shows the preview of my input file. Here are my column names in a CSV file, right? So it's a good idea to keep your column names descriptive and avoid spaces. And here is the preview of an object where my data is going to be loaded into. I have my headings in bold, and here are the values. So now, here I'm going to say yes, because my headings are already in the first row. If I say no, then I've got a problem. R is going to name the variables for me, which I don't want. And it's going to treat the first row as values. That's not what we want in this case. So we're going to hit yes. Now, NA. This is a representation for the missing values. This data set has missing values. We're going to discuss it. Alright, so I'm going to go ahead and click import. What happens? Here, this runs this command on my behalf, right? So this is an object, equivalent is an object, and I'm reading the CSV file located in this folder right here, right? This is a folder, and I'm reading it into data frame called equivalent. Now, it's running another command for me, view. Now, keep in mind, view, V is uppercase. R is case sensitive, and in parentheses is the name of the data frame, right? So here what it does is it opens up the preview in a tabular format. So here are my column names, my variable names, and so on. Notice that right here in the environment tooltip, it's no longer empty. It's showing the data that I just loaded, and it has 303 observations and 14 variables, and I can even expand it and see what my variables are and the variable data types. So in this case it's numeric, but we'll discuss it further. So now what I could also do is, see this, I've got some commands. As you're working on your assignments, the commands need to be run in a sequence. For instance, you set the working directory first, then you load the data, then you do data preprocessing, and so on. The data that you loaded is in R memory, and it's only there for the duration of the session. When you log in, when you restart the RStudio again, you would need to redo all of the commands again. But I want to save time. I don't want to retype all these commands all over, right? So what I can do is, here's this file, new file, rscript. File, new file, rscript. What that will do is, this is a script. The file with extension .r. I can put all my commands in a file and save it. And then when I open the file, I just run it. I can run command at a time, or I can run everything. But I usually do one at a time because I want to see what happens. Alright? So let me close this. But instead, I'm going to open a script that I prepared for today's presentation to save typing. So what I'm going to do is, look this, file, open file. See this? It goes by default to the datasets folder. Why? Because I said that folder is my working directory, but instead, I saved my file on the desktop. So I'm going to find my file, it's in here. Introduction to RStudio, I open my file, there we go. So now, here, this hash means that the first line is a comment. If you may have seen it in other programming languages before, comment is not an executable code. The purpose is just to document the code so that another developer or anyone else can go in and modify and read what I'm doing, right? So here, this is exactly the same command right here that I ran. Now, view is exactly what I did here, right? So now what I'm gonna do, this command is gonna be your friend, head, this one, let's do this one. Oops. Why did I get an error? Because I misspelled, right? So we have to make sure that we spell it correctly. That's what error means. It says object not found. It's because I'm a bad speller. So let me go ahead, I'm gonna save it, and I'm gonna run the head command right here, run. There we go. So what it does is, it shows you the first 6 data rows. So you have your variable names in the first 6. Default is 6. If I wanted to show more, I could specify the second argument to this command is the number of rows, right? So now, suppose that I want to do it, and I'm lazy to type. What I could do is I can hit the up arrow key, up and down arrow keys, right? All those navigating through the command history. Then I put comma, and then I'm gonna write the number of rows that I want to see, perhaps 10, right? Tail is similar, but it's just gonna show me the last 10, right? So head first 10, and tail the last 10. Now, str command is going to show you the data frame structure. Now, here, see this? In the environmental window equivalent, this is a data frame, alright? The data frame is an object into which we loaded the data from CSV file. So we have these variables, alright, and so on. So what I could do is I could also run this command, str, right? Run right here. So this is going to display me pretty much almost same information as here. Number of variables and number of observations. Now, what you could also do is you can do names. Names command is going to show you the variable names, right? Names of your variables of the data set. Now, attributes, it's going to show you it's going to show you the variables and the values. So let me do this. Let's do Control C, Control V. Let me show you this first. So here, I'm going to go run. So see this? It's going to show me everything. It's going to show me my variable names. It's going to show me that my object is a data frame. And here, basically, R names the rows for me. It's just going to number them. But if I'm interested to see only the variable names, that's another way. One. See this? Now, dim command shows the dimensions. Run. So that means the first number is the number of observations and the number of variables, right? So nrow command, and now notice that this is what? A vector, right? Everything is a vector. So the vector contains 2 elements, number of observations and number of variables. So now what I could do, I can do nrow command. So this is going to show me the number of observations. Alternatively, I can type my dimension command, dim, and type 1. So that means I only want to see the first dimension. Now, to show the number of variables, ncol, or you can do length, or you can do dimension and show the second dimension, or in R you can nest the commands, right? So see this, do you remember names? It's going to give me the names of my variables, but if I do length command on names, it's going to tell me how many variables I have. Now, here, very important question to understand. What is the difference between str command and another command is a summary? Str command shows you the data structure, such as variable names, their data types, number of observations, right? Summary command is going to show me the descriptive statistics. I'm going to hit run. So what is this? In this case, it's going to list me all of my variables. Here is a variable name, right? Currently, at the moment, all my variables are numeric. The variable is numeric if the value is a continuous number. For example, age is a continuous number, right? Okay, in this case, it's a numeric, right? So here I'm going to scroll down to see this NA. NA stands for missing values. So this means that I have two observations where this variable is missing a value, and we're going to discuss missing values in more details. See this? CA, right? That's a variable missing 4 values. So now it's very important to keep in mind different variable data types. This is numeric, but for some data mining methods don't work with numeric variables. So you would need to do, we're going to discuss it today, the discretization or the binning, right? So now another option here is that over here I'm showing you the descriptive statistics for all variables. Suppose that my data set has 200 variables and I'm interested only in age. Am I going to scroll through my 200 variables and to look for an age? Of course not. So here how we can do it, we put summary command, and in here we can list just one variable. To do that, we put the data frame name, which is colon, we put a $, and here we put age. Now, very important, you want to make sure that the capitalization is correct, right? You want to get the correct capitalization, because if I put age in a lowercase, it's not going to know what I'm talking about, right? So, there we go, but let me show you on purpose. If I do this, it's not going to know what age is, because there is no such a variable, right? So what I have to do is I have to make sure I type it correctly, right? So this shows me just for one variable. Now, there is a function called lapply, and this is similar to the loop. What it's going to do is it takes the data frame name, and this is a summary. So what it will do is it will run this summary command on every variable in equivalent data set. So let me go ahead and hit run. See this? So that's basically almost the same output as from the summary command, but different, it's just different format a little bit. Now, what you can also do is, suppose that I'm not interested in all of this. I only want to know the minimum. I can do that, right? Now, suppose that I want to know the minimum and maximum, I can do that. And now, if you've noticed that the summary command output does not have the standard deviation. But if I want that, I have to run the SD command, which stands for standard deviation. And the input is variable. Input is my data frame name, $, and then the variable name. And you need to keep in mind that all variables are case sensitive. R is case sensitive, right? So let me go ahead and run this. So that's going to show me the standard deviation, right? So, but guys, yes, if you have questions, go ahead and type them in the chat, and then I'm going to get to it, and I'm going to be answering the questions. And if some of you may have had me in other courses, you know that I like a lot of questions. Right, so now here, let's look at this subset. Earlier, I showed you the head command, right, which actually shows you the first 6 rows by default. Alternatively, there is another way to take a subset, and let me run this here. So what does this do is, in parentheses, you specify the row, in a bracket, rather, you specify, here is the rows that I want, and here I put the variables that I want, right? So data frame name, rows, comma, variables. Now, notice here, this is blank, right? If it's omitted, it means that I want all my variables, right? So in this case, I'm displaying it. But what I could do is I could create another variable. Let's say I could create a variable new equivalent, right? And I'm gonna set it equal to this, right? So here, this is an assignment operator, right? So what I could do is, this is a new variable, and I'm gonna go ahead and I'm gonna run this command right here. Run. See this? I created a new variable. So if I go to here, you see it here? Well, sometimes there are gonna be occasions when you would want to split the data set into portions, and you're gonna see it later on in the course where you would split the data into two parts, and you use the first portion to build your models, and you use the second part to validate the model, right? So this is one way, right? Now here, if I only want the first 6 variables, I'm just gonna specify I want variables 1 through 6, right? Now here, this is a little bit different. I can specify variable names, right? Instead of saying that I want to have variables at position 1 through 6, I can just list the names. Remember, names is going to return me the variable names, right? There is more than one way to do it. I'm just showing you multiple ways, and the copy of this script will be uploaded to your classroom with the WebEx recording. Now, here what it did was it took the columns 1 through 6. What if I don't want column 2 and I don't want column 3? I only want 1, 4, and 5. Now, what C is? C is a list, right? So if I do something like this, C 1, 4, 5, right? It's gonna create a list. It shows me a list of 3 elements. So that's basically what it is. Here I specify my rows 1 through 5, and here I want variable at position 1, position 4, position 5, right? So what is it gonna do? This is what it's gonna do, right? So I can go back here and I can verify which variable was at position 1, 4, 5, right? Now, what we can also do is, suppose that I don't know on what position my variable is. I have perhaps 200 variables. Am I gonna go in here and scroll? No, I'm not, right? If I know the variable name, I can just list it here, right? So I can just go ahead and list, right, like this. C means a list. I'll go ahead and run this. Here, next command, I'm omitting the rows, right? Blank Kamo, it means it's gonna take these 2 variables and all rows. In this case here, I'm not storing it into anything. I'm not creating another variable, right? I'm not doing it, so this is not stored anywhere. I'm just displaying it. Now, I'm gonna show you how to add a variable to the data frame. So here is our data frame. Right now we have 14 variables. Suppose that I want to say everybody gets 1 year younger, right? So what I can do is I want to add a variable called new age, right? And I'm gonna set it to whatever my age currently is minus 1. Now see, this is a must. I can do it because age is numeric, right? So what is this will add? I realize that currently new age is not one of the columns in equivalent data set, but R is going to create it for me. So let me go ahead and run this. See, this equivalent is a data frame name, $, and a variable name, right? So let me run this. Okay, how do I know that the variable was added? Well, there is more than one way to know. I can go in here. I can see the structure, right? See this? It's at the bottom right here. And you can go ahead and compare it with an age. That indeed my calculation is correct, right? I could do that. But I could also use the names command, right? Names equivalent. So there is more than one way to do this. Now I changed my mind. I don't need this column anymore. To remove the column, you just set it to null. To remove the column, you set it to null. You run it. After you do that, make sure to validate it. And to validate it, you can run the names command to display the variable names, right? Or you can just do the head command to preview the first 6 rows, and you'll see that the variable no longer there, right? There's more than one way. Now, let's say sorting. Suppose that I want to know the youngest 5 people in the data set. How am I going to do this? To do this, I have to sort my people by age, right? So one reason you would want to sort is if I want to know the top 5 and the bottom 5. And this, you're going to see it later on in a course, especially when you start doing the association rules, when you start sorting the rules by metric, right? So here, this is very important. Sometimes I want to see the top 5, the bottom 5. So let me create another data frame as a copy. And what I'm doing here, I'm specifying that I want my new data frame to take everything from Cleveland data frame. I want it ordered, and I want it ordered by the column age, and I want to take all data rows. I want everything, right? I want to take all data rows and all columns. See this? I'm omitting it in here. I'm not specifying the column. I want to see everything. I want to get everything. So what I do is I'm going to run now, and I edit another object called Cleveland sorted. It's almost a copy of Cleveland, except the data is sorted by an age. How do I do this? Let me run the head command right here. Run. So here it is. I'm sorting ascending by the age, right? So if I have to know the youngest 10 people, well, I can do it by the head command, or I can take a subset. Anything will work. But now I know who to take, right? Now here, let me do this. This is how you do this descending. To do descending, you put a minus sign. Minus sign means to sort it descending. Let me run this again, and I'm going to do the head command, right? I can also sort by 2 variables. So here it means that I'm going to sort by age, but if I have a tie, it's going to look at the cholesterol level, right? So let me do this, and then I'm going to hit from head here. So see this? I have a tie right here. 2 people are 34 years old. So then it's going to have to look at my cholesterol reading here. All right? Now we're going to look at the variable data type, unless there are questions. Let me see the chat quickly. No, there are no questions. Okay. So let me continue, and let me look at the variable data types. Okay. If you may have noticed that right now, the sex variable, which is a gender, right, it has values 0 and 1. For some reason, it got loaded as an integer, but that's not what I actually intended. I want it to be a factor, where 1 is a male, perhaps 0 is a female. So there is a function called factor. What it's going to do is it's going to convert the numeric variable into the factor variable. Factor variable is a variable that has a discrete set of values. It's a set of predefined values. The values are not continuous, and very often we know what the values are in advance. So let's go ahead and let's run this. Run. Now, notice that right here, the structure, it's showing me that it's a factor. Levels means the values that the variable can have. 0 and 1, right? Those are two values. Here, what 2 means is that it means that the first observation has a value 1, the second observation has a value 1, right? So that's the second level. This is called levels, and so on. So some data mining methods that you're going to see later on take only categorical variables or factor variables. You're going to see these words interchangeably in the book. Alright, so now I'm going to run the summary command, but I'm only interested in the sex variable because that's a variable that I just worked with. Now, my statistics are going to change. It's going to show me the values and the number of observations that have each value. Right, so I have 97 people who are females and 206 males. An alternative way to do the frequency count is to do the table command, table run. Now here I missed something. What I want to do is I want to take another variable here, CP, and I'm going to convert it to a factor also. And to validate, I'm going to run the summary command. Now here, this one right here, table is going to show me the frequency count. But what I could do is, I can show the frequency count by gender, right? So basically what you do is you put two variables like this. So basically, you're showing the CP values of 1, 2, 3, 4, right? And here are my gender. I'm showing the breakdown by gender. That's what the table command does. And something else, you can use the table command to draw the pie chart. The pie chart command takes the table command as an input. So in other words, I'm taking the frequencies count as an input, and every slice of the pie chart is going to be proportional to the count. So let me run this here, pie. So now in my plots window, I'm going to see this chart that I just ran. And each slice is proportional. And if you guys interested, you can even play around further. You can type the question mark and you can type the command name, enter, and here you have a help page. So basically you can play around with colors, you can play around with labels, you can do the radius, right, how big your chart is, and so on. Right? So this is, I'm going to leave this for you to explore at your leisure, but this gets really interesting. Now what I'm going to talk to you about is that discretization. So as I mentioned earlier, some data mining methods do not handle the numeric variables such as age. But the problem I have here is that age is a continuous. Age values are continuous. There is no predefined set of values that exist. I cannot use my factor command the way I did on sex and CP variable, because I don't have a set of specified values, right? I don't have a set of predefined. Like for instance, I can have a 5-year-old come in, right? That currently we don't have. So what I have to do is I have to use the binning to divide the people into ranges. For instance, I want to group people by younger than 25, it's just an example, between 25 and 40, between 40 and 60, and this is what you more likely see on the surveys. On the questionnaires, usually you don't see the age, you see the age range, right? So basically, discretization is going to convert the continuous variable into the value ranges. But to do this, we have to install the package called rules. In RStudio, all code is stored in packages. So here, my packages. There is a user library and there is a system library. System library is what comes when you install the RStudio. These packages come in when you install the RStudio. But unfortunately, some functions that you're gonna use are not included in the installation. You need to install it. And to do this, you run this command, install that packages, and in quotes, double quotes, you put the package name, right? I'm not going to run this command because I have a package installed already. And it's going to show in here, in this upper section, right here. Very important thing to keep in mind is that when you install your very first package in RStudio, the very first, you might be prompted, because we cannot explicitly download it into the program files. You will be prompted if you want to install it into the local directory. The user library, this is a folder, I'll show you, this is a folder. It's going to be in your documents folder. You're going to see R subfolder, and then it's going to be Windows, Win library, and then there's going to be subfolder 3.3. Yes, it's going to be 3.3. And inside the 3.3 folder, I have a separate subfolder for every package that I install. Here is my rules, right? So when you download the package, you're going to see it right here. You're going to see a folder with that package name. But very often, it's possible to run into a little bit of technical challenges when you install your very first package. And at times, it works if you don't get the pop-ups. At times, you may want to add this folder manually. In the documents, put R, win-library -3.3, right? You will create that folder. Another alternative to install the package is in here, Tool, Install Packages, and here you would specify where you want to install it, but in here it saved it, right? I set this as default. So here you would just type the package name, right? So now, this is very important here. After I install the package, am I ready to use it? What's going to happen right now? Let me just do it on purpose. See this? It could not find the function discretize. Why? Because the package is not loaded into memory. The packages that come with RStudio installations are loaded into memory. User library is not. This is something that I need to remind myself to do each time I want to use the package. Right? So one way to load the package is just to run the library command and a package name in parentheses, or this is another way. I can go in here, packages, and I can check this. And R is going to run this command on my behalf. Okay, so this is in double quotes. Here it's showing me where my package is installed. Right, that's a location it's a folder that I just showed you a minute ago. Now, here, this is a message. Some of you may decide that it's an error. No, it's not. In this case, it's not. It just informs me that the package was loaded. So if the message is read, it might not necessarily be an error. And here, it just loads in the dependencies, I think. Now, the A-rules package contains a function called discretization. Very important, there are different types of discretization. I can do it equal interval. For example, I can say I want people younger than 25, I want people between 25 and 50, 50 and 75, and above 75. So that's going to be equal interval because the ages range is approximately the same. It's approximately the same, right? So here I'm just going to do the 5 intervals. Well, it's not going to be 25 in this case. It's not going to be 25. younger than 25, between 25 and 50. It's not going to be like that because it's going to look at my maximum and minimum value, right? It's not going to be exactly like in my hypothetical example. So let me run this, right? But how do I verify what happened? I want to verify that my variable is discretized as expected. And notice that what I did was here, I added a new variable. I added a new variable to my data frame called equivalent. Just in this case, just to show as an example of what happens, I did that, right? Usually, you would want to discretize the variable itself, but I'm doing it just for this exercise. And now, how do I know that my variable is no longer numeric? I can look it up right here, right? I can see my variable. Here, see this? It shows factor, 5 levels, right? And if you see the parentheses like this, it means the boundary is excluded. And if it's a bracket, it means 29 is included here. So here it's showing me that the values were split into 5 value ranges. And also I could do this. I could do summary, right? And I'm going to type my variable name, right? See this is nice. And then I put my $sign here, and it's giving me this pick list right here. This is nice. It helps you minimize the typos. See this? So it's showing me the value ranges and the number of observations with the value in each range. So when I'm telling you, interpret the results right here, verify that discretization worked, what you need to do is you need to look at the summary command on a variable before you run discretization and a summary command on a variable after running the discretization and compare. That you no longer see the minimum, maximum value and the mean. What you see is you see the value ranges, right? So in this case, you have an ordered factor variable. It's an ordered because, see here, if an individual has an age in this range, right? An individual with an age in this range is younger than an individual with an age here. Where we had before, where the gender was not ordered, right? This one is ordered, it has an order. Now, what I could also do is, let's do frequency. Basically, frequency will aim to have approximately the same number of people in each age range, right? That's what it's gonna do. And I can also specify the boundaries. This is called fixed, or you may also hear it's called user-defined. And in the categories, C is a list. Here, negative infinity, it means negative infinity. Basically, see, this is the first point is 30, so negative means below 30. And here means everybody older than 70, right? So let me go ahead and run this now. And now, what I can do is, let me run the summary command on the whole data set. So see this? It's just showing me how many people have a value in each range. Eventually, this is going to be a problem when I have only one value in a value range. Is going to be eventually a problem. And you're going to see it when you start splitting data into the training and test data. But you'll see it later in the course, but just giving you heads up. So here, to solve this, I would have to reconsider my boundary points. Something like that. But for now, we're going to leave as is. Earlier today, I mentioned missing values. And let me show you why missing values could be a problem. So notice that equivalent, right? There is a variable called CA. And some of the observations have a missing value. So let me see, what if I want to see the mean of that variable only, right? So we know that summary command ignores the missing value, but min command does not. Oh, NA. See this? Some of you is gonna say, wait a minute, why did I get an A? Min is a valid command. I did not mistype my variable name. Well, it's because the variable has missing values, right? And another way you can see that, one way to see that there are missing values is the summary command, right? See, this summary command shows that there are 4 NAs, 4 missing values, right? So what we're gonna do right now is, let's calculate the mean, but this option, NA.rm, means that I want to ignore my missing values when I do the calculation. Now, here, T is the same as uppercase true, right? And A.rm equals true, uppercase, but I'm lazy typing, so I can just put uppercase T, and R is gonna know what I mean. So let's see, let me run this. See, now it works. By default, the default value of NARM is false, so you have to explicitly set it to true if you want to know the variable mean and the variable has missing values. Now, suppose that I want to show which observations have at least one missing value. Here is a subset, right? Remember, the bracket is a subset. If over here, after the comma, if I'm not listing anything, it means I want to see all variables. Here, I'm specifying the conditions for data row, right? Complete cases, by itself, complete cases means that no variables are missing a value. And this is the negation. The exclamation point is the negation. So here, my condition is I want to display a row if at least one variable is missing a value. This is what it's going to do basically. Run. So now I know that I have 6 observations that missing at least one value, one or more value each, right? So now notice that it wraps because the values of all variables don't fit in the window width. So it's going to wrap it for me. That's why you see it in 2 sections. Now, how do we handle missing values? Depends on how many data rows we have, how many instances we have missing a value. Are they missing values of the same variable? Or how big is my data set size? So if my data set size is relatively large and there are only a couple observations, and suppose that those couple observations in question are missing values for most of the variables, I can go ahead and I can just omit the observations with missing values. Now, NA_omit. NA_omit is gonna remove the observations that have at least one missing value. Right? And here I pass the data frame. What I'm gonna do in here, I'm going to create a new data frame called new equivalent, and I'm gonna set it to a copy of the equivalent data frame, but I don't want to see the observations that have missing values. So NA omit. Remember NA, right? Missing value NA. So let's go ahead and run this. And note that, so basically here I can see that, oh, and why am I having 17 variables? It's because I added 3 variables earlier. I added 3 variables earlier when I did discretization. That's why. So now let me see here. See this? I had 303 observations. Here I have only 297 because I removed the observations that were missing at least one value. Right? At least that were missing a value of at least one variable. See this? I removed those 6. And you want to verify, right? you can, sometimes you want to verify. If you run this command again, what you could do is to verify. You can do the summary command, right? And you're gonna see that there are no more missing values. That's one way. There is more than one way. Or you can check. You can try to display the missing cases like I did right here. Except equivalent, you're gonna put new equivalent, right? Oh, here it is. I'm doing it. And nothing got returned, right? 0 rows. So that means that my new equivalent data frame does not have any instances missing a value. Now, let's talk something else here. Is deleting the instances with missing value always a good idea? Suppose that my data set is small. Sometimes I could have just few instances missing a value. What I could do is I could fill in my missing values with the variable mean if the variable is numeric. So what I'm going to do right here is I'm going to reset the new equivalent to equivalent. I'm just going to reset it back. Here what I want to say is that I want to say if my variable CA is missing a value, right? That's what it's doing. It's saying if the value of this variable CA is missing, take the mean of the variable CA and replace it with the mean. Now, here, when we calculating the mean, we have to specify to ignore the missing values. Otherwise, we won't be able to, right? Remember it? Earlier, I demonstrated that we have to specify explicitly an ARM equals true. It means the calculation is going to ignore the missing values, right? So here, what I'm going to run this command. Here, I'm not deleting any data rows. See this? I still have 303, right? So that's one way you can handle the missing values. You can replace with the mean. It's not in here, I think, but just wanted to say that sometimes, suppose that you have a variable that's missing a value for perhaps 1/2 of the instances. In this case, you're not going to replace it with a mean. You're not going to delete half of your data set. It might be better to just remove the variable. So the solution, the approach you take, depends on the structure of your data, depends on how many values are missing, on your data set size, and so on. Now here, this is a little bit more complicated, but you're going to have a copy of this script. Since sometimes my decision is impacted by how many observations are missing a value, sometimes I want to calculate this, right? So let me see what this returns. Let's run. This is very tricky. What this does is for every variable that I have in a data set, it's going to calculate the number of data rows, the number of observations that are missing a value of that variable. I realize it's a bit complex, but I wanted to show you this. So this is called an inline function. This is an inline function, right? Sum. It's called sum. And here is an A. It's going to return true if the value is missing, right? If the value is missing, it's going to return true, and it's going to do the counts for me. Here, 2 means that I'm looping through every single column at a time, right? So that's parameter 2. That's what it is. So here it's just showing me which variables have a missing values and how many values are missing. See, the CA has 4 missing, this one has 2 missing, and so on. So this is just for you useful command to have. And if you need to use it, you will just copy the command and you're gonna put your data frame name instead of my data frame name, right? It's a code reuse. This is what you're gonna do. You replace equivalent with the data frame name for your data, right? And that's all. Now, here, what I could do is I could do data visualization. Let me show you that. You can do the histogram, right? That's my histogram. And again, I can play around with the titles. So if you do the help command, right? It's just showing you examples of how to change the title main parameter is specifying the title, right? And you can change the axis and you can change the colors. And I'm gonna let you explore it. Now we have the bar plot, but remember it has to take the frequency count as an input, right? And to do the frequency count, we have to use the table command. And this is a discretized variable. So I want to plot how many people are in each age range. Yep. So I realize it does not look pretty, but I'm just showing you an idea for right now. And if you got the box plot, and we have the plot where you use one variable for x-axis and another variable for y-axis. And here I can just plot my frequency counts like this, and L means that the type is a line, right? So now remember what I've been doing here. I saved this script in this file, right? So what I could do is I'll make sure that the copy of this file is posted with the presentation recording. Now, I've been speaking for about an hour. Now it's going to be your turn to ask questions. And let me see the chat. Okay. I see there are several packages. How do you figure out what package you need for a particular project? And how do you know what related commands? Okay. This is an excellent question, Emmanuel. I like it. What you could do is you can read the help system. There is an online help system for R, and it shows you the list of packages and what each package does. So if you go online and if you go to the R pages, you can Google, you can type R packages, right? And there's a lot of latest documentation. This is grant contributed packages, and you're gonna see the list. This is the archive, the previous versions, and you would need to look at the current version. And here it is, table of available packages sorted by name. So this is available at the CRAN web page. And here, see this? I have a brief description for each package and what it does. And the first package that if you are in introductory course, the first package that you're gonna use is rules for discretization. And if you're in advanced course, you're gonna use the text mining packages to analyze the data in the text files. But in introductory course is rules. Discretization is the first package that you're gonna use. And if you scroll down, basically for any package, you can click here. And here you're going to see more documentation. You can see dependencies, right? Because the code in a package could depend on some other packages. And some packages even have vignettes where you got examples. And here is the reference manual. You can click here. And here it's going to show you what's in a package. It's going to show you examples and each method. So that's one way. Another way is that suppose that I know the package, suppose that I know the name of my package, and I'm going to go to RStudio. Suppose that I know my package is a rules, right? I can type question mark, and I can put, oh, okay. I'll tell you why. It's because I never loaded the package in the memory. I never loaded the package in the memory, so it does not know. What object types can be used with lapply? I mostly use the data frame. I use the data frames mostly. Yeah, but what you can do is, to learn more, I'll show you in a minute. Now, here, I hope I answered this question. See this? This shows you information about the method. But suppose that I want to know what packages I can use with lapply. What I do is I put my question mark and I put lapply. I want to read about this command, and here it's showing me which variables I can use. See this? I can use an array, right? I can use it I can reuse it on something that has a vector, right? By default, returning a vector, and here it is. lapply returns a list of the same length as x, each element of which is a result of applying a function. So basically, the data structure that you have, it should be of the vector format. So data frame, you can see it as a vector. It's a set of variables, right? Here, it's showing me the difference, lapply, sapply. Here it is, see this? Usage. Yeah, and it's showing a bunch of examples here. Argument. This has to be a vector, right, or an expression object. And here, see this is an object of type list, right? Anything that can be as a list, for example, as a data frame. So let me know if I'm answering the question, right? So see this? So basically, I've been using it a lot on the data frames, and the nice part about it is that you don't have to write the loop, right? I know that some people would rather not write the code, they would rather write the shortcut. So this is an excellent question, and I want to see more questions. I like questions. David, I hope I answered that question. Let me know. But you want to make sure that the variable is a vector, right? So let me know what other questions we have. I love questions. Questions are great because they're just good. It's really helpful to see which areas you need more information on. I recall some tricky situations where lapply did not do. Oh, I don't remember. Well, that's an excellent question, but well, yeah, that's true. Very often we don't get the results that we expect. And there's something else that I wanted to point out, that if you have an error message, if you receive an error message, it's quite possible that someone else already received the same error message. So what you could do is, if you take a message and you copy and paste into Google, more likely you're going to see a discussion about that error. And you're going to see what other people try to do to solve this problem. You're going to see what other people try to do. And you can try their suggestions, right? And if that does not work, then you're going to post a question in the classroom. You're going to say, hey, this is what I've been trying to do. This is the result I expect. This is the result I got. I have tried this and that, but it did not work for me. And then either TA or your classmate is going to step in, right? And if your classmate knows the answer, that's a great way. Yeah, great participation. Yeah, but yeah, very often that's true. And yeah, something else I wanted to point out is that make sure that you guys have the latest R version. Please install the latest R version, because it's highly possible that some code in the homework assignments may not run in the earlier version, right? And the latest version is 3.3.1. So the difference between 3.3.0 was just a small patch to 3.3.1. But 3.3 was a big change. Even you notice that the folder name is 3.3, the folder name in the libraries, it's 3.3. And if you had an older version, you had 3.2. But now we are in 3.3, right? So you want to have, you'll have 3.3. And when you do upgrade, unfortunately, you will need to install the user packages again, unfortunately. So something very important for you guys to keep in mind that now I run discretization method. It worked. It worked perfectly. I was happy. Tomorrow I restart my RStudio again and I try to run the same method. It does not work. Why? This is what I need to do is I have to check what package is my method in, right? I have to check if the package is loaded into memory, and I have to check if I'm typing the method name correctly, right? But the same command, it worked today. If it does not work tomorrow, I have to look through my code because the command follows a sequence. I need to see what did I do yesterday that I did not do today, right? So the good thing is that if you saved everything in a script, then you can just rerun the script. You don't need to rewrite all the work that you did, right? That's a plus side. And it's saved in the file with .r extension. Okay, so let me see. I had series of issues last fall with packages. Were incomplete. Package A requires version 2. This is an excellent question. Well, the way I do it, I just try to install the latest version of all packages whenever possible. Or another thing, what you could do is when you install the package, you can have an option to install all of the dependencies when you upgrade. And when you load, you can also choose to install the dependencies. But yes. Oh, your classmates cannot see the questions that you are asking. But basically the question is that very often you have a package A that requires version 2 of package B, but package C requires the version 1 of package B. So this is a really tricky situation, and we need a specific example to know how we handle it. But yes, this is highly possible. It is possible. And when you load your packages, right? So suppose that package A requires version 2 of package B. So I'm not going to load package A and C at the same time. I can load just package A, and it's going to load the version 2 of package B. It's going to load the dependency, right? That's what it's going to do. But when I load the package C, I cannot load the package A anymore. So sometimes you may see it's going to prompt you to restart the R session. It's possible. It's highly possible. So, but yeah, question, when you ask a question, if you type it to me privately, no one else can see it. But if you type it to everyone, then everybody can see it. So that's why I repeated the question. But David, it was really an excellent question. I like it. So, guys, I want to see questions. This is a perfect opportunity for you to ask questions. Going once. Going twice. If you don't have any more questions, then I'm gonna call it an evening. And I would like to thank you all for participating. So I'm gonna go ahead, I'm gonna stop sharing. And I'm going to end the recording. Here it is.